which of the following is equivalent to the complex numbers shown above? And then we got this big hairy mess here where we want to take the rational expression 1 plus I over 1 minus I and then add that to 1 over 1 plus I. Well, when you add two fractions like this, what you might want to do is find a common denominator. And the easiest way to find a common denominator is to take the product of both of these things. Let me just rewrite everything. So we want to take 1 plus I over 1 minus I, and then add that. And let me switch some colors just so we can keep track of things. And then add that to 1 over 1 plus I. And actually, let me give myself some space here. So plus 1 over 1 plus I. Well, we're able to add two fractions if we have the same denominator. And we can have the same denominator if we multiply both the numerator and the denominator here by this denominator, by 1 plus I, and if we multiply both the numerator and the denominator here by this denominator. And this is the way that you've always added fractions with unlike denominators. We're just finding a least common multiple, and that least common multiple, the easiest one, is just multiplying the denominators. So let's do that. So let's multiply the numerator and denominator here. So put some parentheses, times 1 plus I, and let's multiply the denominator here, times 1 plus I. So notice 1 plus I over 1 plus I, that's just going to be 1. So we aren't changing its value, we're just going to find another way of expressing it. And this one over here, we want to multiply the numerator and the denominator by this denominator, by 1 minus I. 1 minus I. So we're going to multiply times, we're going to take this and multiply 1 minus I, multiplied by 1 minus I over 1 minus I. And once again, this thing right over here is just 1, so we're not changing its value. We're just finding a good way to rewrite it so that we're going to have the same denominator. Notice both of these denominators are now going to be the same thing. They're going to be 1 plus I times 1 minus I. But let's figure out what this is. So this first one right over here, so the numerator, so let's see, we're going to have 1 times 1. Actually, let me do this in different colors just so we can keep track of everything. So we have this numerator right over here. 1 times 1 is 1. 1 times I is I. I times 1 is I. And then I times I is negative 1. And then this denominator over here is going to be, so we're going to have divided by 1 times 1. And you could say that this is a difference of squares right over here. Well, let me just all multiply it out. We'll see that it's a difference of squares. So 1 times 1 is 1. 1 times plus I is plus I. Negative I times 1 is minus I. And then negative I times positive I. Well, I times I would be negative 1, but then we have this negative, so it's just going to be plus 1. And so what does this simplify to? Let's see, you're going to have 1 minus 1, so those cancel out. And then you're going to have this I minus I, that's just going to be 0. So this simplifies. In the numerator, you have 2 times I, and then in the denominator, you have 1 plus 1 is equal to 2. And I could simplify this, but my goal isn't to simplify this. My goal is to have a like denominator. So I'm just going to leave this like this, just like that right now. And now let's move on to this one. So the numerator here is pretty straightforward. 1 times 1 minus I, that's just going to be 1 minus I. And then the denominator here, 1 plus I times 1 minus I, we just figure that out. That simplifies to 2. So this has now become 2I over 2 plus 1 minus I over 2. Well, what's that going to be? Well, our denominator is going to be 2. You could say we have 2I halves plus 1 minus I halves. So how many halves is that going to be? Well, we want to add, this has no real parts, so we want to add the imaginary parts. So we're going to have the 1, this one, and then we could take 2I and then subtract I from that. 2I minus I is going to be I. So it's going to be 1 plus I over 2. And they don't have exactly that, but if we just, instead of writing it like this, if we viewed this as 1/2 times 1 plus I, which this is the same thing. Or if we view this as 1/2, if we distribute the 1/2, 1/2 plus 1/2 I, or plus, let me just write it, 1/2 plus 1/2 I. And when we write it that way, we see this choice is exactly that. And we are done.